Imagine waking up to a world gone still, not just quiet, but fundamentally wrong. The Earth, our spinning home, stops rotating. No sunrise, no sunset, just a frozen planet. The familiar rhythm of day and night vanishes. Cities on one side bake under endless sunlight, others plunge into perpetual darkness. Winds howl at hurricane speeds, oceans surge, and gravity shifts in bizarre ways. The Earth's rotation, a 460 per second spin at the equator, has powered our climate, ecosystems, and lives for billions of years. What happens if it stops overnight? Would humanity survive the chaos? Could life adapt? What would become of our planet? Let's dive into this apocalyptic thought experiment, exploring the science, the devastation, and the faint hope for survival. Buckle up for a journey into a world where the Earth stands still. The moment the Earth stops spinning, physics unleashes chaos. The planet's rotation generates a centrifugal force, slightly counteracting gravity, especially at the equator. When this stops, everything not bolted to the ground, people, cars, buildings, keeps moving at the Earth's rotational speed due to inertia. At the equator, that's 1,670 km/h, 1,038 mph. Imagine standing in Quito, Ecuador. You'd be flung eastward, tumbling like a rag doll. Cities like Nairobi or Singapore would see skyscrapers topple, cars catapult into buildings, and people hurled into debris. Even at mid-latitudes like New York or Tokyo, moving at ~200 km/h, the sudden halt would be catastrophic, leveling weaker structures and injuring millions. Only at the poles, where rotational speed is near zero, would the effect be minimal. Winds erupt as the atmosphere, still moving at rotational speed, slams into the now static surface. Supersonic gales up to 1,000 mph at the equator rip through cities, shredding forests and flattening suburbs. In Los Angeles, palm trees snap like twigs. In Mumbai, shanties disintegrate. Oceans, also in motion, don't stop either. Massive tsunamis, hundreds of meters high, surge across coasts. London, Sydney, and Miami drown under walls of water. Inland areas flood as rivers overflow. The Earth's crust, suddenly free of rotational stress, triggers global earthquakes. Fault lines like the San Andreas or Japan's subduction zones unleash quakes exceeding magnitude 9, collapsing bridges, dams, and highways. Volcanic eruptions follow as tectonic plates shift, spewing ash and lava in places like Iceland or Indonesia. Within hours, the planet splits into extremes. One hemisphere faces endless day, scorched by unrelenting sun. The other plunges into eternal night, freezing in darkness. Temperatures in the dayside tropics soar past 50 degrees C, 122 degrees F, baking cities like Bangkok or Rio. Nightside regions like Moscow or Toronto drop below degrees C, -58 degrees F, flash freezing infrastructure. Power grids fail as plants overheat or freeze. Communication networks, satellites, internet, phones, collapse as antennas snap in winds or servers fry. Humanity, if not wiped out by the initial chaos, faces a world unrecognizable, with billions dead or stranded in a fractured, hostile landscape. The Earth's rotation drives its climate, from trade winds to ocean currents. Without it, the planet's weather systems collapse into chaos. The dayside hemisphere, under constant sunlight, becomes a superheated desert. Temperatures in equatorial regions like the Amazon or Congo climb to 60-70 degrees C, 140-158 degrees F, evaporating rivers and igniting wildfires that rage unchecked. Vegetation wilts, crops like rice or maize burn, threatening food supplies. The night side, cloaked in darkness, freezes into an icy wasteland. Glaciers form rapidly in places like Canada or Siberia, entombing forests and cities in ice. The twilight zones, narrow bands between day and night, like parts of Chile or Scandinavia, offer the only semi-habitable climates, with temperatures fluctuating wildly but potentially survivable. Ocean currents like the Gulf Stream halt without the Coriolis effect, caused by rotation, disrupting heat distribution. The Atlantic cools drastically, starving Europe of warmth. Coastal cities like Lisbon or Boston face erratic storms. The oceans themselves redistribute due to gravity changes. Without rotation, the Earth's shape, slightly flattened at the poles, bulging at the equator, shifts toward a perfect sphere. Water pools at the poles, flooding Arctic and Antarctic regions, while equatorial oceans recede, exposing seabeds near Jakarta or Mombasa. Atmospheric circulation collapses, creating stagnant, toxic air pockets on the dayside, where CO2 and pollutants accumulate, choking any surviving life. On the night side, air grows thin and frigid, making breathing a struggle. Weather becomes a patchwork of extremes. Hurricanes linger in twilight zones, tornadoes spawn unpredictably, and dust storms blanket deserts, turning places like the Sahara or Gobi into suffocating wastelands. Human infrastructure, already battered by the initial halt, faces relentless decay. Skyscrapers, weakened by quakes and winds, collapse under thermal stress, expanding in the dayside's heat, contracting in the nightside's cold. Cities like Dubai or Shanghai crumble as steel frames buckle, glass towers shatter, littering streets with debris. Roads, like the Trans-Canada Highway or India's Golden Quadrilateral, crack under temperature swings or flood into muddy rivers. Bridges like Rio's Celarón Steps or Venice's Rialto succumb to floods or quakes. Power plants, nuclear, coal, solar, fail within days. Fukushima-style reactors leak radiation. Coal plants in China or India choke on ash. Renewable energy, like wind turbines in Denmark or solar farms in Arizona, breaks under extreme weather. Communication systems vanish. Satellites thrown off orbit by gravitational shifts crash or drift uselessly. Internet servers fry in overheated data centers or freeze in icy ones. Cities like Seoul or San Francisco, hubs of tech, become silent relics. Transportation grinds to a halt, airports flood, railways warp, and ports like Rotterdam or Singapore sink under polar-bound oceans. Survivors, if any, face isolation. Hospitals without power or supplies can't treat injuries from the initial chaos. Food stores spoil in the heat or freeze solid. Supply chains, reliant on global trade, collapse. Societies fragment into small, desperate groups in twilight zones, scavenging for canned goods or hunting wildlife. The global population, decimated by the initial cataclysm, dwindles further as starvation, exposure, and disease take hold. Life on Earth, adapted to a spinning planet, faces existential challenges. Plants, reliant on day-night cycles, struggle. On the day side, tropical species like orchids or palms burn under constant sun, their photosynthesis overwhelmed. Nightside plants like Siberian pines or tundra grasses freeze or starve without light. Only twilight zone flora, hardy species like cacti or alpine shrubs, might adapt, though erratic storms threaten even these. Animals face similar fates. Diurnal species like birds or primates suffer on the night side. Nocturnal ones like bats or owls perish in endless daylight. Migratory animals, monarch butterflies, Arctic terns, lose navigational cues, collapsing populations. Marine life fares no better. Coral reefs bleach in overheated equatorial waters, while polar oceans freeze, trapping fish and whales. Evolution, however, begins to work. Twilight zone species adapt. Rodents develop thicker fur. Birds shift to crepuscular habits. New ecosystems emerge in these narrow bands, with fungi and algae thriving in damp, temperate zones, but biodiversity plummets. Estimates suggest 70–90% of species could vanish within decades, rivaling past mass extinctions. Humans, if any survive, face genetic bottlenecks, with small populations in twilight zones struggling to rebuild. Food chains collapse as apex predators, like lions or sharks, starve without prey, while scavengers like vultures or crabs briefly thrive. Microbes, resilient to extremes, dominate, breaking down organic matter and reshaping soils. Earth's biosphere, though battered, clings to life in the margins, a testament to nature's adaptability. Fast forward 1,000 years, Earth is alien. The dayside is a scorched desert, its cities like Cairo or Miami reduced to sand-covered ruins. The nightside is a frozen wasteland, with Moscow or Anchorage buried under glaciers. Twilight zones, stretching across parts of Patagonia or Norway, host patchy ecosystems, scrubby forests, resilient wildlife, perhaps human descendants living nomadically. The planet's new shape, a perfect sphere, stabilizes, with oceans pooled at poles, creating vast polar seas and dry equatorial belts. Stone structures, pyramids, Machu Picchu, endure though eroded. Plastics fragment into microparticles, littering sediments. Radioactive waste from reactors lingers, a hazard for millennia. After 10,000 years, little remains of humanity. Alien visitors might find petrified tools, rusted satellites, or faint radio signals drifting in space, piecing together a lost civilization. Earth's magnetic field, weakened without rotation-driven dynamo effects, exposes the planet to solar radiation, eroding the atmosphere over millions of years. Life persists but in forms unrecognizable, new species adapted to a static world. The cosmos, indifferent, watches as Earth becomes a relic, its story a fleeting chapter in galactic time. If the Earth stopped spinning, the devastation would be unimaginable. Cities flattened, climates warped, life pushed to the brink. Yet this thought experiment reveals our planet's delicate balance and humanity's fragility within it. Rotation drives our days, our weather, our lives. We can't stop the Earth, but we can protect it. Climate change, pollution, overexploitation, These threaten the systems we take for granted. What will you do to preserve our spinning world? Conserve energy, protect ecosystems, advocate for sustainability. These choices matter. The future's unwritten, but our actions today shape what endures. Let's cherish our planet's rhythm before it's